Today we will cover the last two question types in this chapter. Okay. So both these will include the projectile projected along an incline. Projected along an incline. So let's see what are the two approaches that one can use. So in fact, the two approaches that I'm going to talk about, how do they differ from each other? It's all about the coordinate system that you choose to approach the problem. So what are the two different choices of the coordinate system we have? You can choose the coordinate system along the incline, one axis along the incline and one axis perpendicular to the incline. So that can be your choice. Or you can continue to keep your x along the horizontal and y along the vertical. Whether you choose xy coordinate system, whether you choose x dash, y dash, equally good. But personally, I like the one where we have the x-axis along the incline. So let's talk about the two approaches. I'm going to briefly talk about the one where you take x dash, y dash. Here, if you take your x-axis along the horizontal, y along the vertical, then think of incline as another trajectory that the projectile will intersect. Okay, so the point where it hits the projectile hits the incline. Let's say the coordinates are xp, yp. So if the incline angle is alpha, then tangent alpha will be yp divided by xp. So you can use this to figure out the coordinates of xp and yp, and then you can, that means you have your range then. And what is the range in this scenario? Range is the distance covered along the incline, So this is the range. Okay. So I'll let you guys explore that approach. So today I'm going to focus on the approach wherein I'll take my x-axis along the incline and y-axis perpendicular to the incline. And let's find out the time of flight. Let's find out the range. And let's find out the maximum distance. Maximum distance the projectile moves away from the incline. So let's quickly establish those three things. Any questions before I dive into it? No questions, okay? So this is x, this is y. Now, to begin with, let's figure out what is the acceleration along the x-axis and along the y-axis. Okay. Now, can somebody tell me? So if I take this point, if I draw, let me choose a different color. This is my G. What is this angle, beta? If this is alpha, what is this angle? Is this angle alpha as well?
Yes, sir.
Okay. So the component of G perpendicular to the incline is G cos alpha. Along the incline will be G sin alpha. Any doubts here? No doubts. Okay. So now for the two directions, x and y, note that unlike the typical scenario of a projectile, where we do not have any acceleration in the along the x-axis, which is along the horizontal, and we only have the acceleration g along the vertical. In this scenario, we have accelerations along both x and y, along both x and y. So how would I write my the equations, the kinematic equations, the two independent kinematic equations for x and y? For x, the two equations would be, or rather, I'm not going to write the vxt is equals to uxt minus gt. Rather, I would focus on the xt equation. So xt is equals to, this is u, this angle I've taken as theta. So will it be u cos theta into t minus of g sine alpha t square. Once again, this is the component of velocity u along the chosen x-axis, which is along the incline, and g sine alpha is the acceleration along the x-axis. So your x coordinate is uxt minus half axt squared. Similarly, for the y, I can write my two equations as yt is equals to u sine theta t minus half g cos alpha t squared. Okay. If you are interested in finding the velocity component at certain time t, then we can always use Vx is equals to ux minus g sine alpha t. And here we can write Vy as uy, which is u sine theta, minus g cos alpha t. Typically, we don't use this equation, but anyway, they might come in handy if the situation demands so. Okay. So let's figure out the, first of all, range. Can somebody help me figure out the range? How do I find the range? Range is this distance. So Vibita, can you quickly help me determine the range? I can use the fact that my y displacement is 0 between this point, right? If my initial point is the launch point, final point is the landing point of the incline, that the displacement, net displacement, starting point to the landing point is 0. So I can use the equation and I can write 0 is equals to u sine theta t minus half g cos alpha t square. And I've 1 t from both the terms. This is what we get. So the time of flight then is, so t, the time of flight then, 2u sine theta divided by g cos alpha. Does anyone have any issue with this?
No, sir.
No. Okay. So once we know the time of flight, then we can put that back into our equation B, which is xt is equals to u cos theta minus half g sine alpha t square. So I can write my range as u cos theta into 2u squared divided by cos alpha minus half g sine alpha into square of this term. So 4 u squared sine squared divided by g square cos square. Yes, Peter? You guys are okay with this, no?
Yes, sir.
Let's simplify it a little bit. So I'm going to take u square, 2u square out. In fact, I'm going to take 2u square out. Rather, I'll take 2u square sine theta divided by g cos alpha. I'll take them out. What we get? So we get cos theta minus, we will have sine theta sine alpha divided by cos alpha. Yes, Peter? Clear?
Yes, sir.
So can I write this as u squared sine theta cos of theta plus alpha by g cos square alpha. Yes, Peter? This is your range. Now, if you want to find out the angle theta for which the range is maximum, what do? So we say dr by d theta should be 0. I'm going to treat these as constants and I'm not even going to write them. I'm straight away going to write the derivative of that. It will be cos theta, cos of theta plus alpha minus sine theta and sine of theta plus alpha. This as 0. So this gives us cos of 2 theta plus alpha is equals to 0. Is that right, Peter? Which means 2 theta plus alpha is equals to pi by 2. So your theta is pi by 2 minus alpha, half of this angle. Half of this angle.
So एक बार वो dr d theta क्या है? समझ नहीं आया.
Beta, to find the angle theta for which the range is maximum, we differentiate the range. Remember, if you have a function, if you have a y equals to some function of x, you plot it, then how do we find these extremums, right? The maximas and the minimas. We take derivative of y with respect to x. And what is this? This is the slope. This is the slope of the curve. We say whenever the slope of the curve is 0, that means we have a maxima or minima there. We have an extremum there. Is that part clear?
Yeah, yes, sir.
Okay. So if that part is clear, then we can move here. So that's what we did. Theta, we differentiated it. And this was all a constant, 2u square g cos square alpha. It is not changing. It is not varying. It is not varying with theta. That's a constant. So when you equate that to 0, that constant will disappear anyway. So that's what we have done. So now if you put theta as this, then what do we get for the range? What is the maximum range? What is the maximum range? R maximum. So we have 2u squared upon g cos square alpha. That is, so I can write sine A, 2 sine A sine B. How can I write that? 2 sine A sine B, cos B, 2 sine A cos B. Can I write this as sine of A B, sine of A minus B. Yes, beta? So we can write 2 sine theta cos theta of alpha, cos of theta plus alpha as, so we can write that as sine of 2 theta plus alpha plus sine of, let's say, theta minus theta plus alpha. So sine of minus alpha, so minus sine. Ruchika, Chavi beta check. If issue here. I've just written this here. The sine theta into cos theta plus alpha as this. This is pi by 2. The range is maximum. So this will become 1. We have u square by g cos square alpha into 1 minus sine alpha. Is that clear, beta?
Yes, sir.
Now this is true when we have thrown the projectile upwards. How will this change if we throw the projectile downwards? What will change, beta? What all will change?
Sir,
Yes, beta. So question is, what all will change if we throw the projectile downward? When we take this angle as the angle of projection, yes, beta? And now the G has two components, G cos alpha, and this is G sine. So the two equations will then become xt becomes u cos theta into t plus half G cos alpha, and your yt will be u sine theta times t minus half, sorry, I made the mistake here, this should be G sine alpha minus half G cos. The rest of the logic is the same. We'll again find the time of flight first by finding out the time it takes for this displacement to become 0. So we get t. Once you put that in this equation and you get the range. So can I leave that with you guys? What the equation? It should be 1. What is it, Ruchika? If you recall, beta, is alpha in the denominator? Or shall we solve it right now? What do you guys prefer? Let's solve it. So time of the flight once again is 2u sine theta divided by g cos alpha. So if I put that in the range, so your range will become 2u square sine theta cos theta by g cos alpha plus g u. So g will cancel out. We'll have u square sine square theta divided by g cos square alpha. We'll repeat the exercise. Take for the range, we'll take 2u square out, square sine theta divided by g cos alpha, and you are left with cos theta cos alpha plus sine theta plus sine square theta, right? So you'll have cos theta cos alpha plus, is it right? Feels like I'm doing something wrong here. Maybe not. Cos theta alpha. Maybe we did something funny in the last one, even though. Okay. In any case, 2u square sine theta was taken out. We were left with cos theta. Right? So cos theta plus sine square theta upon cos alpha. That's what we have. No. Sine theta out. This is simply sine theta.
तो फिर भी sin theta sin alpha आना चाहिए ना?
We are missing this term, no? We are missing
Yeah.
we're missing
हाँ.
sine alpha term. That's why everything seems to be going. Right? So you have sine theta, sine alpha. Now this makes sense, correct? No? So what will this be? This will be cos of theta minus alpha divided by cos alpha, correct? 2u square theta cos of theta minus alpha divided by g. Is that right? Yes, Peter? We'll follow the same steps. This is the range. To find out what value of theta is this maximum. So we're going to differentiate. So we get cos of theta minus alpha. And then we'll say minus sine theta, sine of theta minus alpha. Okay. We say then this should be equals to 0. So what is this? Cos of 2 theta minus alpha is equals to 0. That is 2 theta minus alpha is equals to pi by 2. So alpha is equals to 2 theta. Sorry, theta is equals to pi by 2 plus alpha. Earlier we had it other way now, right? So we had pi by 2 minus alpha. Now if you substitute this back, what do we get for range? What will be the maximum range, beta? So I'm going to say, so I'm going to use u square upon g cos square alpha. I'm going to write 2 sine theta cos of theta minus alpha. Again, I'm going to use sine of a plus b, and then plus sine of a minus b. What will that give us? Sine of a plus b, that is sine of 2 theta minus alpha, right, beta? Minus sine of a minus b.
जब प्लस नहीं होगा
So what I'm writing is 2 sine A cos B. This will be plus sine of A minus B. Right. So that will be your minus theta plus alpha. This will become U squared upon G cos square alpha. This is 1 plus sine alpha. Yes, Peter? And by the way, we could have simplified these equations. See, we can write square alpha as 1 minus sine square alpha. We can write this as U square upon G 1 minus sine alpha. Correct? In any case, now let's quickly find out the maximum distance from. How would we do that, Ruchika Beta? How would we find the maximum distance of the projectile from the incline? So Chavi Beta, so same thing, right? So we can
सर मैक्स हाइट निकाल रहे हैं ना
maximum height, maximum distance from the inclined plane. So we'll use at this point, projectile's velocity in this direction becomes 0, right? So Vy is 0 here. So if we use that, so then that means the time it takes to reach to that point is U sine theta divided by G cos. Take it, beta? So this time t and put it back in your equation yt, maximum height at G. Okay, beta?
हाँ सर
Okay, good. Let's solve one problem and then we'll move on. And I know we intended to finish this session early today. So let's see if we can do. So let's solve the 2019 problem and then I'll leave the rest of the problem. So at least we'll go through all the problems with discussion. We'll not solve those problems, but discussion. Perimeter. 2000 JEE means question. 2019 JEE means question. Well, this is simply asking for in any case.
सर अप्रॉक्स 20 आ रहा है.
Okay. This is not what I was expecting. Okay, so this is anyway. So this is in meters. So what do we get here? This is 0.732. Ruchika, have you taken the same approach?
Yes, it's a similar approach. Yes.
Chavi,
Yes, sir.
you got the same thing?
Yep.
That's about 19.5 centimeters.
Yeah. Yeah.
Let's take a look at why we couldn't solve it. This is so lengthy. Hmm. Okay. So let's quickly go through the anti-abhyas questions. So what do we have here? We have the block shown in the diagram has a mass of 2 microgram, a charge of 2 into 10 to the power minus. By the way, in this question type, not only do we have the questions involving projectile motion along the inclined plane, but we also involve scenarios wherein you have acceleration in the horizontal direction as well as the vertical direction. Because after all, that's what we just did. So for the projectile, if you take your x and y, x along the incline and y perpendicular to the incline, then you have acceleration both in the x and y. And we learned how to solve those problems. So this is the offshoot of that. So for example, in this scenario, you have the mass m that is being thrown from a certain height, and the electric field that has been turned on, and this mass m has a charge, uh, 2 into 10 to the power minus 19 coulombs, which means it will experience a force. What will be the magnitude of the force? Q times the electric field QE. So the horizontal direction, so there will be a horizontal acceleration besides the gravitational acceleration downwards. And then they're asking for the range. Okay, so first we need to figure out the time of flight. This is the time it will take for the block to reach the ground. Once you have that time, then you can do your equation for x, that will be uxt minus or plus half at square, plus half at square. The force is in the direction of the motion, so it has a positive acceleration. So its speed will increase. Its speed will increase. Is that clear, Beta? Yes.
Yes, sir.
Similar thing. Now, instead of the electric field, there is that imparts it a horizontal acceleration per second square to the left, right? And the projectile has been thrown theta with the vertical. If the vertical component of the initial velocity, the wind imparts it to the left, the angle at which the ball must be thrown so that the ball returns to the boy's hand is theta. What is the value of 10 times tan theta? This is an interesting question. So this is the ground. You have to throw the ball at certain angle. The wind is blowing in the opposite direction. So when you throw it in this direction, the particle is gonna go up, and then it's gonna come back. Please go ahead and solve this one. I think this is definitely an interesting question. For students on YouTube, we are going to cut short the broadcast a little bit short today, but at least hopefully you got the gist of what we are covering in the class today. So do drop me a note in the comment section if this is something that you would want to participate in going forward. If yes, then I would highly encourage to take a look at the website, because that's what we are using to practice our problems in the class. So once again, I'm going to stop the broadcast here, and I'll see you on coming Monday. The classes are from Monday to Thursday, 5:15 to 6:15. And in the next class, in fact, we'll have another class tomorrow as well. So we're going to start with force and motion. So in the next class, we'll start with force and motion, and we'll go from there. So take care. I'll see you tomorrow.